Hi, in this video, I'm gonna start a series where we are gonna build a peer-to-peer or P2P network. This is gonna be decentralized. The only constraint is that you need to be connected on the same network, on the same router, and this works with any two different devices with IP addresses. In this first video, we are just gonna build. I'm gonna teach you guys the foundations of sockets of connection. We are gonna build a. In this video, we are gonna build a program that sends a message from one computer to another. In later videos, we are gonna improve this by adding, for example, files, by adding images, videos, voicemails. So let's see. In this first video, again, I am aiming to teach you guys the foundations. So hopefully the series will go well. So we got the sender, we got the receiver. I created two different Python files for them, and then we also got the generate function. No, generate fernet. What is this generate fernet? So we need to encrypt our message, right? Otherwise, when we send our message to other computer, right? Somebody can interfere with it. So we are encrypting it using the fernet encryption method. Now, fernet isn't the best encryption method out there, but we are starting with fernet since it is the easiest one to teach. And then we might move to other encryption methods. So let's first create our fernet encryption key, which the fernet uses a specific key. We get this key by fernet.generate key, right? So this generates a binary string, then we can print it actually, this binary string. So we are using Python and you need to install cryptography by saying pip install cryptography. I guess that's the only thing that you need to install. Yeah. I'm opening my terminal, right? Then Python generate fernet.py. So we got our fernet key here, right? Yep. We copy this. So this is gonna be the key that we are gonna use. The problem is that both receiver and the sender needs to have the exact same key on their Python files. So key equals to this. So both receiver and the sender somehow need to transfer the key. Now, cool. Let's start with this sender, since I think it is easier to teach. Now we don't need to generate fernet because we already generated our fernet key. Now we need IP address, right? So IP equals to this IP is going to be the IP address of the receiver. And you can just view your IP address by opening command prompt or whatever, then writing ipconfig. This works on Windows laptops. Mine is Windows. So when I hit enter, it will show my IP address. Okay, I got my IP address by typing ipconfig and then copying the IPv4 as here. So this is the IP address. This is dynamic. This is assigned by my router to me. This is not public, so sharing this won't cause any problems. This is again the IP. When you type ipconfig on your Windows laptop, and then you see IPv4 there, and it writes your IP address. This is not public. This is just assigned by a router, and it allows the router to know which device owns this IP address. So when a package reaches my router, it will scan the IP addresses, and when it sees my IP address, it will send the package to my own computer. Okay, so this is the IP address of the sender. I'm gonna write both files. I'm gonna run both files on the same computer. That is why I'm entering the IP address of my own computer. But basically, you need to enter the IP address of the receiver's computer, right? Yep. So we are gonna again cover the receiver later. Let's continue with the sender. Now we need to create a socket connection, right? So we can say client equals to socket socket dot this and socket dot this. So what are oops yeah. So what are these? So socket dot socket, this basically allows you to create a it allows you to connect with your network and send packages, receive packages. You're basically creating a socket, right? And then this first parameter means the socket that AF inet. So this allows you to send packages or receive packages through your IP addresses, right? This AF inet stands for IPv4, which is the IP address that we copied, and this allows you to send and receive packages. This is using IP addresses, and this is just a way of sending and receiving packages. This uses the TCP protocol. Um, you can just search them up. They are kind of technical. So yeah, but there is some good documentation out there regarding these definitions. So you can definitely check them out. Now we create our client, right? Then we need to make a connection. Before making a connection, we need ports. So the receiver will allocate a port on their device. What is a port? You can imagine ports as doors to your computers, right? When your computer will receive a package, it receives through ports. The ports are ranged from 1 to some high value, which is, I think it was around 50,000. We are going to use 5,000, which is kind of default for these um, I don't know, tutorials, I would say. You shouldn't use the same port on two different tasks. We are gonna the receiver will allocate the port number 5,000 on their computer, meaning the receiver will say, I'm opening the port 5,000 to receive packages, and the sender will send that package to specifically port 5,000 so that the sender sends the package, the receiver receives it. Yeah, and to create a connection, use socket client dot connect. We say, so this is going to be a tuple, and then the address, which is, let's make this IP. So the address is going to be IP, and to a specific port. So this will make the connection, right? And then this basically allows us to connect with the computer. Then we're gonna say while true. So we are gonna get the message through the input box. We are basically prompting our computer to input a message, right? And then we are gonna encrypt that message, then send it. So when we wrote client.connect, we are not sending anything. We are just connecting with other device. We are saying our network that we are prompting both computers that the connection is made, right? We are not sending anything. To send stuff, we first gotta input a message, right? Yep. And then we're gonna encrypt it. Encrypted message equals to encrypt it, we use Fernet, which we before using Fernet, I think before using Fernet to encrypt it, you gotta say Fernet equals to Fernet key. So we are creating a Fernet instance using the Fernet library. We are passing the specific key that we created. So this Fernet instance will help us encrypt stuff. So we gotta say Fernet dot did I write it correctly? Yeah, I wrote it correctly. Fernet dot encrypt. We are encrypting using this key, right? And then we are gonna encrypt our message. But before encrypting, we gotta encode it. What is encoding? Now, our message is a string, right? When we input something, we get a string. But Fernet cannot encrypt strings. It works with binary. That is why we encode it to binary. So this basically changes our message from a string to a binary. Then we encrypt it, right? So this is now our encrypted message. Then we are gonna send it. Now we say client.send encrypted message. This is all. This is all that we need. Yep. I hope there are no problems. If there are, just type it as comments and I'll answer them. Hopefully this works. Yep. Now let's see the receiver part. Again, we need to set a port, which is 5000, and we also need to create the Fernet key. So this is gonna decrypt the message, right? And then we also need to again create a socket connection, but before we gotta name it server. I mean, you don't need to name it server actually. I just named server since this is the receiver end, and this acts as a server. So this we say socket.socket, and we put the same stuff here. Socket.sockstream. Cool. Now we created our server, right? Everything looks fine. Now we are saying our server to bind this with port. What does it mean? Now we are basically saying our server to allocate this specific port on your computer, which is 5000, to accept connections from any IP address. This basically means any IP address. You can put a specific IP address there, and that means that that port will only connect with that IP address. But when you put an empty string, that means that that specific port 5000 on your computer can connect with any IP address. So we gotta say host, and instead of saying empty string, we gotta say, I will say host here to make it easier to read. Then we are gonna say server.listen one. What is this? Well, this basically tells our computer to accept only one device. So if let's say device A connected to device our own device, then the port 5000 will only be allocated for device A, and for other devices, for example device B, will not be able to connect with our computer's port 5000 since it is connected to device A. So this basically means that we are allocating the specific port to only one device. Cool. Now what do we do? Then we gotta say connection and then address equals to server dot accept. So what is this? Now, when we say server.bind, we are not making a connection. We are just allocating the port for a specific host, right? In this case, the host can be anything. But when we say server.accept, this basically means that when a connection request is made, we are accepting it. Here in this line, we are accepting a connection request. This basically states that the con is for connection, and the addr is for the address that is requesting connection. Yeah, so basically the address is the computer that is connecting to our own device. Connection is just connection, you know. You can print out address, so you can play with this code. If you didn't understand something, you just print it out. Like, what is this fernet? You can say, you can try to print out like print fernet and see what is this printing. Is this printing an object? Is this printing a string? Like, you can just test them, try, which I believe helps with the learning. Okay, so we accepted the connection. Now what are we gonna do? We accepted it, but we are still not receiving the files, right? That is why we are saying file true. right? Data, yeah, okay, sorry about that. Data equals to server dot receive 1496. What is this? Now this basically means that this line, we have our, this is not going to be server, by the way, this is connection. We are saying that for our device connection, right, we receive something, we already accepted it, so when something is sent to our own device, we receive it. 4096 stands for the buffer size, which is, if I'm not mistaken, is the maximum bytes that our computer will receive, I think. So if you put this, make this bigger, then your computer will receive, you can receive bigger files. But if you make it bigger, then your computer will allocate more memory because you're receiving a large package, right? So in this case, we are just using 4096, which is, I think, kind of good for a messaging app. Like, it might be even default. I'm not sure. Yeah. And in later videos, when we are transmitting or receiving, sending packages, what we are going to do is, so for example, a PDF file will probably be larger than 4096 bytes, right? So what we are going to do is, in the future, we are going to divide the PDF file into chunks of equal sizes, for example, 4096, 4096, 4096, and then we are going to send them separately, and the receiver will receive them, and then it is going to create a single PDF file from those specific chunks. So if you make it like extremely big, you can send a PDF file in one go, but that again has its own drawbacks. Your computer will allocate memory. I mean, there might be some network issues, router issues, so I'm not sure. Like, yeah. Okay, so we received it. What are we gonna do now? So if data, if not data, so break. So what this does, if we didn't receive anything, right? Just break it. We didn't receive anything. By breaking the while loop, we are exiting the receive end. So what this means is that when the sender stops the connection, right, the receiver will break out of this while loop. Now we use try, right? We are saying message equals to fernet dot decrypt data dot decode. What is this? Now we get the message equals to, right, fernet.decrypt data.decode. Remember that, oops, the decode shouldn't be here, it should be outside of this parenthesis. Yeah. Okay, so what this does. Now we received our data, right? What we did is, in the sender end, we first converted the message into binary, then we encrypted it, right? First binary, then encrypted. Now we are gonna first decrypt it, right? When we decrypt it, we get a binary message, then we decode it into a string, right? So this is what we do here. It is because first we decrypt it, then we convert it to a string. Okay, now then we can easily print the message. And we also need except exception in case an error occurs. We say an error occurred. Okay, in case an error occurs, we use try except stuff, which, yeah. Then when we exit the while loop, we say connection.close and server.close. So we end everything. So this is all. takes to create a peer-to-peer messaging app. This is not actually a messaging app since there is just one fixed sender and one fixed receiver. In our later videos, probably in the next video actually, we will make this dynamic, meaning both sides can send and receive messages. But for this video, we are only sticking with one sender and one receiver to make it easier to understand. So let's actually run this. So we need to first run the server python receiver.py. It is running. Then I create another python sender.py. Again, I'm running this on my own computer. This is because you can, I guess, but you can just try this on different computers too. Sender.py. Yep. So both are running. Yeah. So say hi, how are you? We send it, and then I come to the receiver's terminal. We see it's printing hi, how are you? So how this works is that sender sends a package to your internet router, and that router sends it to your receiver since you entered your IP address here. This doesn't work if both devices aren't connected to the same internet because then you would need public IP address, which we are working with private IP addresses. As I said before, this is dynamic, this changes. This is assigned by your router so that your router knows which device is which. We are sending the package message. We are encrypting our message. We are sending it to our router, and our router sends it to the specific IP addresses, specific port, which is our receiver. And receiver accepts this. Receiver receives the package with a specific maximum bytes range, bytes value, whatever. And then we decrypt it, we decode it from binary to string, we print it. That is basically all. Which one was which? Can you see my message again? See, this is the receiver, it is receiving it. Again, in later videos, we are gonna make this work for both sides, I guess. Both sides will be able to send message, both sides will be able to receive messages. So that's all for this video. By the way, I ended this code with Control C in case some of you might not know. When you press Control and C, it ends the code. And realize that our receiver code already ended because we have break in here. That's why. So that is all for this video. If you have a question, please leave a comment and have a great day.